Okay, in this next section, we're going to be looking at the method of undetermined coefficients. The method of undetermined coefficients, we have already learned it, but for differential equations of order 2, linear differential equations with constant coefficients of order 2. Now we're going to apply the same method for differential equations that are linear, constant coefficients, but of higher degree. The good news is that the method works exactly the same. There is no difference whatsoever. So as long as the function is as long as the differential equation is linear with constant coefficients, the method works. And although the method of undetermined coefficients is not as general as the method of variation of parameters, it usually is much easier to use when it is applicable. It is not as general. The other method, the method of variation of parameters, is more general because you actually have a formula that gives you the solution. But really, when the method of undetermined coefficients works, when it is applicable, it is much easier to apply, to implement. And that's because for the other method, even though you have a formula, the formula depends on the Wronskian. The Wronskian is a determinant, and if you have a differential equation of order n, then you have to compute an n by n determinant, and that can get pretty nasty pretty quickly. You will need a computer for that. But for this one is not too bad to actually do by hand when the method works. So here's an example. So let's find a particular solution, then the general solution for this differential equation. Okay, first let's find the complementary solution. So first the complementary solution. So first we solve the associated homogeneous differential equation. So first we have to solve this one. Third derivative minus 3y double prime minus 3y prime minus y equals 0. Okay, first we have to solve this one. Okay, so let's solve this one. To solve that, first start by writing out the characteristic equation, which is in this case r cubed minus 3r squared plus 3r minus 1 equals 0. Okay, this we can factor. There's several ways of factoring this. You can do grouping. You could do let's do the rational roots theorem. Okay, so for the rational roots theorem, possible values, possible roots are, remember, this is plus or minus divisors of the last number, the constant number, which is 1, over divisors of the leading coefficient, which is also 1. So that, and see, and looking at the combinations, well, there's only one combination, 1 and 1. That means the only possibilities are 1 and negative 1. So let's start by trying 1, see if it works. So this is going to be 1 cubed minus 3r plus 3, oops, sorry, minus 3. R is 1, so 1 cubed minus 3 plus 3 minus 1. This is 1 minus 3 plus 3 minus 1, which is 0 indeed. So that means that r equals 1 is a root. That means r equals 1 is a root. So r minus 1 is a factor. So r minus 1 is a factor. Okay, so let's figure out what are the rest of the factors. So r minus 1 is a factor. Again, you could do long division or you could use synthetic division. I'm going to do synthetic division again. So this is now write the coefficients of this polynomial. This is 1, -3, +3, -1. And then outside you put 1. Okay, now the process begins. Bring this one down, then multiply. 1 times 1 is 1, put it there and add down, that's -2. -2 times 1 is -2, add down, +1. 1 times 1 is 1, put it there, add down is 0, which we expected the remainder to be 0. And now this is the result of the division, which means that the polynomial, this polynomial right here, factors as, well, you have this one, r minus 1, and the other one is this, which is r squared minus 2r plus 1 equals 0. Okay, now for this one, you can factor it or use the quadratic formula, but actually factors. This is r minus 1. These factors are r minus 1, r minus 1, which equals 0. So actually then we have the r equals 1 multiplicity 3. R equals 1 multiplicity 3. Okay, that allows us to then write down the general solution of this equation, which we call, remember, we call it the complementary solution of this one. So now we can write the complementary solution. So the complementary solution, we have that the root is 1, multiplicity 3, right? So this is going to be c1 e to the 1t, which is just t, plus c2, remember, now you multiply, this is a repeated case, c2t e to the t plus c3 t squared e to the t. And that is the complementary solution. And I'm going to box it up here for easy reference. Okay, so that is a complementary solution. Now we're going to guess a particular solution, right? Remember, this method of indeterminate coefficients is just the educated guess method. So we're going to make the educated guess based on the non-homogeneous term, based on the non-homogeneous term here. That is a constant times e to the t. So the guess should be also a constant times e to the t. Okay, however, note that there's an overlap here. That means this cannot be a good guess. It's not going to work. It's already there. So actually that means if you try this, it's not going to work because it's going to be a solution of the homogeneous equation, not of the original non-homogeneous equation. So it's not going to work. So then that doesn't work, right? So then let me do this. That's not good. So when it doesn't work because there's overlap, you multiply the educated guess by t. So it would be at e to the t. And now you look at that, that also doesn't work, is still overlap. So nope, that is not good either. So then you take that one and you multiply by t one more time. So this is going to be a t squared e to the t. And that's still not good enough because there's overlap there. You cannot use that. It's not going to lead to anything new. So then you multiply by t one more time, and the educated guess is going to be a t cubed e to the t. That is going to be our guess. So we're expecting a solution to be of this form. Now there's no overlap there. Okay, so expecting the solution to be like this, we're going to now plug it in, the differential equation, and figure out what a needs to be. Okay, this differential equation is order 3, so we're going to have to find the derivative of this 3 times, which is not very fun, but let's do it. So this is going to be first derivative is going to be, okay, this is a product rule. The first times the second. The derivative of the first, so this is 3a t squared, derivative of the first times the second. Okay, good. Plus the first times the derivative of the second. Awesome. So then simplifying, this is a t cubed plus 3a t squared e to the t. Okay, so that is the first derivative. Now let's do it again. It's not too bad. Second derivative. The derivative of the first, the derivative of this, so this is 3a t squared, and the derivative of that is 6a t, the derivative of the first, times the second, plus the first times the derivative of the second. And now simplifying, let's combine, you're going to get a polynomial. This is a t cubed, and then these two right there are like terms. That one is that one. So you get plus 6a t squared plus 6a t e to the t. Okay, that's the first derivative, that's the second derivative. Now let's do the third derivative. Third derivative. Okay, third derivative. The derivative of the first, so this is going to be 3a t squared plus 12a t plus 6a. That's the derivative of the first times the second plus now the first times the derivative of the second, which simplifies to, let's combine the polynomials. You get a t cubed, what are the like terms? This one is a like term with this one, and these two are like terms. Okay, so then you're going to get 9a t squared, adding those two, adding these two you get 18a t plus 6a e to the t. Okay, and that is the third derivative. Now we're supposed to plug this in, the differential equation, which is this one right here. So I'm gonna start by writing this side first. So you get 4 e to the t equals, and now let me copy the difference. This is third derivative minus 3 yp double prime plus 3yp prime minus yp. Okay, we have all of these. We have to now start plugging in. This one is right there. Sorry, this one. So this is going to be a, so I'm just going to basically copy this stuff. Plus 9a t squared plus 18a t plus 6a e to the t minus 3yp double prime. Yp double prime is right here. So minus 3a t cubed plus 6a t squared plus 6a t e to the t. Then plus 3y sub p prime. Y sub p prime. Y sub p prime, that is right here. So I'm just going to copy that. Okay. So 3, oops, a t cubed plus 3a t squared e to the t. And lastly, minus yp. Minus yp. Yp was our guess, right? Uh, okay, this is going to simplify nicely though, because there's a bunch of like terms. Okay, what are the like terms? First, look at the at cubed. All of these have a to the t, so they're all like terms. I mean, I could just add the polynomials. So this is that, 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 and that. Okay, look at those. You get at cubed, and then this one, because you have to distribute the negative 3, you got minus 3 at cubed, and then positive 3 at cubed, so those two cancel. And then you have a negative a t cubed. So that one and that one cancel, so you get 0 for the t cubes. You get 0. Now let's do the t squares. So the t squares, you get that one, and that one, so you get 9. But remember, this 6 is actually being multiplied by negative 3. So you get 9 minus 18, 9a minus 18a, that's negative 9a. And then you got this 3 and this 3, that's a positive 9a. So negative 9a and positive 9a gives you 0 for the t squares. So there's no t squares. For the linear terms, 18at minus 18at means there's no linear terms either. So those cancel. And lastly, for the constant terms, you get 6at, and that is it. You get 6a, 6a e to the t. That's what you get. And now comparing, we get that means that 4 has to be 6a, which means that a equals 4 over 6, or 2/3. So A equals 2/3. And now we're almost done. It does not mean, that means we found the particular solution. So that means the particular solution is 2/3 t cubed e to the t. And once you have the particular solution, remember the general solution is the sum of the complementary solution plus the particular solution. So that is particular solution. And now the general solution is going to be the complementary solution plus the particular solution. Or in other words, the complementary solution, we found that it is right here. So I'm just going to copy that. This is C1 e to the t plus C2 t e to the t plus C3 t squared e to the t, and then plus the particular solution, which is 2/3 t cubed e to the t. And that is the general solution of that. Okay, now let's do another example of how to solve a differential equation of higher order, this time order 4, using the method of undetermined coefficients. Okay, first thing we need to do is, as usual, start by solving the associated homogeneous equation. So, fourth derivative plus 2 double prime plus y equals 0. So first we solve the associated homogeneous equation. Okay, this one is a differential equation of order 4 that is linear and it has constant coefficients, so we solve it by finding the characteristic equation, which is r to the 4 plus 2r squared plus 1 equals 0. This is a polynomial in quadratic form because it has 3 terms. The term in the middle has exponent that is exactly half the exponent of the leading term. So it is, you can factor it like a quadratic basically. So if you factor it, this is r squared plus 1, r squared plus 1 equals 0. So that means r squared equals -1, r squared equals -1 is repeated, so that means solve 1 and then is multiplicity 2. So that means r is plus or minus I. Square root of -1 is I, and then this is multiplicity 2. So that means now that we can write down the complementary solution. The complementary solution is going to be C1. The real part of that is 0, so e to the 0, which is 1, cosine of t plus C2 sine of t. And because it is multiplicity 2, now the next two are the same as this one, multiplied by 2. And of course, you have to use a new coefficient. So C3t cosine of t plus C4t sine of t. And that is the complementary solution. And let's box it up for easy reference. Okay, now we're going to find a particular solution using the method of the undetermined coefficients. So we have to make a guess, an appropriate guess for the particular form, particular solution. And looking at this, This is a combination of sines and cosines, a linear combination of sines and cosines. You see that whatever is in front of the sines and the cosine both are constants. So that means our guess is going to be also a linear combination of sines and cosines. What is in front of the sines and cosines are going to be also constants. So the guess should be a sine or a cosine plus b cosine. So you could write a cosine plus b sine is the same thing. So it doesn't matter. Okay, so that's our guess. However, note that there's overlap. So this cannot be because there's duplication. A sine of t is the same as this term, general term, and then b cosine of t is an overlap with that one. So that cannot be the guess. It's not going to work. It's duplicated with a particular, it's duplicated with a complementary solution. So then that means that means the particular solution has to be this but multiplied by t. That's going to be our next guess. However, note that that's still not good because t sine of t is right here, t sine of t, and t cosine of t is right there. So that also is bad. That's also bad. That's not going to be viable. That's duplicated with the complementary solution. So that means we attempted this one more time, multiply by t throughout. So it's going to be a t squared sine of t plus b t squared cosine of t. Now that one is an appropriate form for the guess, for the particular solution. Okay, so taking it from there, let's find the derivatives and plug them in the dpq. Now, this is going to take a while because we have to take the derivative 4 times. Okay, so take a deep breath and let's get to work. Okay, first derivative is going to be product rule twice, the derivative of the first times the second plus the first times the derivative of the second, the derivative of sine is cosine of t plus. Now product rule on the other one. The derivative of the first times the second plus the first times the derivative of the second, the derivative of cosine is negative sign, so put a minus in there. That. And I remember when we did problems like this before where we had a bunch of sines and cosines, and the easiest way to simplify this is just to collect all the sines and all the cosines together. So let's collect all the sines. So here, that, and that. So this is going to be negative b t squared plus 2at sine of t. And now let's combine the cosines. That and that. Oh, sorry. That too should not be there. That was a mistake. My bad. It was the derivative of the first. So it was 2bt. Okay. And now combining the cosines, so this is a t squared plus 2bt cosine of t. Okay, and that is the first derivative. Now let's find the second derivative. The derivative of the first times the second plus the first times the derivative of the second. Now, product rule there. The derivative of the first times the second plus the first times the derivative of the second. That's going to change this to minus because the derivative of cosine is negative sign. So minus and minus sine minus minus. Okay. And now let's combine the sines together and the cosines together to simplify this. Here are the sines. Let's combine them. Starting with the highest exponent, this is going to be negative a t squared. Negative 2bt and negative 2bt is negative 4bt plus 2a sine of t plus, and now let's combine the cosines. Negative b t squared, 2at and 2at is 4at, and then plus 2b cosine of t. Okay, good. Now let's find the next derivative, which is going to be the third derivative. Okay, two more derivatives. Let's do this. Two more derivatives. Okay, the next derivative, the third derivative. Oh, by the way, let me box that one up because we are going to need it. Okay, now let's find this third derivative. The derivative of the first, which is negative 2at minus 4b times the second plus the first times the derivative of the second. The derivative sign is cosine. Okay, plus the derivative of the first times the second plus the first times the derivative of the second. Now the derivative of cosine is negative sign, so that means there's going to be a negative in front, which we can distribute. So all the signs are going to change, so that's going to be positive t squared minus 4at minus 2b sine. And now let's combine the sines and the cosines. These are the sines, those are the sines. So combining the sines, starting with the highest exponent, b t squared, you have negative 4at and negative 2at, that's negative 6at. And then negative 2b and negative 4b is negative 6b sine of t. And now let's combine the cosines. You have negative a t squared minus 4bt minus 2bt is negative 6bt. 2a and 4a is positive 6a. Cosine of t. And one more derivative. Now the fourth derivative. Fourth derivative. This is the derivative of the first. 2b t minus 6a times the second plus the first times the derivative of the second. Now the derivative of this, the derivative of the first, plus the derivative of the first times the second, now plus the first times the derivative of the second. The derivative of the second is a negative sign. The negative sign, you move it to the front. The negative, you move it to the front and distribute it. So everything's going to change here. So this is going to be at squared plus 6bt minus 6a sine of t. And now combining sines and cosines. These are the sines. These are the sines. Starting with the highest exponent, at squared. 6bt and 2bt is 8bt. And negative 6a is negative 12a. So that's for the sine. And for the cosines, bt squared, negative 6a is negative 8a t. Negative 6b and negative 6b is negative 12b cosine of t. Okay, all that was the fourth derivative. Okay, now we're going to plug in everything in the original differential equation, which is this one. I'm going to start by writing the right-hand side first. So 2 sine of t minus 5 cosine of t, 2 sine of t minus 5 cosine of t is supposed to be equal to the fourth derivative plus 2 times the second derivative plus particular solution. This is equal to, okay, now this is going to be a lot. I'm going to just copy it, but it's going to simplify a lot as well. So I'm copying the fourth derivative because that's what I have to do. Then plus 2 times the second derivative. So now I'm going to copy the second derivative plus 2 times everything in the second derivative needs to be doubled. So I'm going to write plus 2 negative a squared minus 4bt plus 2a sine of t plus 2 times, again, everything in the second derivative needs to be doubled. So minus 2b squared plus 4at plus 2b cosine of t plus yp, and yp was a t squared sine of t plus b t squared cosine of t. Okay, now this is going to simplify substantially. We're going to combine the sine terms. There they are. Starting with the t squared terms, you have at squared negative 2 at squared and positive at squared. So at squared minus 2at squared and at squared, that gives you 0. You get 0 t squared sine of t. So all those go. Now, looking at the linear terms, you get abt negative 4bt, but that's multiplied by 2. So it's actually negative 8bt. So 8bt and negative 8bt cancel, and you have no more. So those cancels, you get 0 t bt. I mean 0 t sine of t. So you get nothing. And lastly, for the constant terms that have sine of t, so you get negative 12a, 2a, and but that's multiplied by 2, so that's 4a, and that is it. So negative 12a and positive 4a is negative 8. So you get negative 8a sine of t. Okay, and now I'll just copy this part. And now combining the cosines, cosine, 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 bt squared, negative 2bt squared, and positive bt squared gives you 0. Though all of them cancel. Negative at, and then positive at, there it is, 2 times 4at, that's positive at, so you have negative at and positive at gives you 0. And lastly, negative 12bt, sorry, negative 12b and positive 4b is negative 8b cosine. Aha, so that's what we get. And now comparing coefficients, you have 2 sine of t equals negative 8a sine of t. So that means that, really, that means that 2, the coefficient of sine should be equal to the coefficient of sine on the other side. So 2 should be equal to negative a, and comparing the coefficients of cosines, you're supposed to get that negative 5 equals negative 8b. So this one gives you what? Gives you a equals negative a quarter and b equals 5/8. 5/8. So therefore, the particular solution is a, which is negative a quarter t squared sine of t, plus b, which is 5/8 t squared cosine of t. That is the particular solution. And lastly, the general solution, oops, the general solution is going to be, let's write it down now. The general solution is going to be the sum of the complementary solution and the particular solution. So the general solution is the complementary solution plus the particular solution. So the general solution is the complementary solution. I have it right here. We did that one. It is all that. Let's write it out. C1 cosine of t plus C2 sine of t plus C3 t cosine of t plus C4 t sine of t plus negative a quarter, now the particular solution, t squared sine of t plus 5/8 t squared cosine of t. All that is the general solution of this differential equation.